Hi, everybody. Welcome back to Dave's Math channel. This is my next video on my daily math problems, which I've been featuring on the Facebook group Classical Mathematics. This is the latest problem I posted in that group. I just posted it yesterday. And the problem concerns representations of even numbers, the sum of two primes. This is the famous problem, unsolved problem known as the Goldbach's conjecture, whether or not every even number is a sum of two primes, possibly equal. Nobody's proven this, even though I think just about every mathematician in the world believes it's true. This is a problem that's been unsolved for almost 300 years. But anyway, let's just begin with this problem. So here's the statement of the problem. I'm asking for the positive even integer not exceeding 10,000, where the most representations is the sum of two primes, possibly equal, as well as the number of such representations. Well, this is a pretty straightforward problem to solve with a computer search using brute force. I don't really know any better way to do it than that. So that's exactly what I did here. And it's very straightforward. I mean, here's the code I wrote in Mathematica. I wrote a couple of functions here, very similar functions. This doesn't solve the whole problem. This code, the function on the left is called sums of yes, sums of two primes of n. That just does exactly what it says. It gives you all the representations of a given even integer, positive even integer, n is the sum of two primes. And I ran it with 90 as the input. And you can see on the bottom, these are just all representations of 90 as the sum of two primes. It turns out that 90 is the smallest number less than 100, or the largest. It has the most representations of all even numbers up to 100, namely 9. 100 itself, I think, has 6 representations. Um, and then I wrote a very similar function on the right, which just keeps track of the number of such representations. Because you don't really need all the representations, you only need the number. You don't have to store them all. So the function on the right's a little bit simpler. And then we're not done with the problem yet. We have to search through all numbers up to a given limit. That's what this function on the left does here. I call that and number max. I forget the name I give it. Max sums of two primes. So this is just gives you the value of n, which maxim up to some limit n max that maximizes the number of representations. Might not be unique. If it's not unique, it stores all the representations, all the values of n with the same number of representations in an array. It turned out every example I looked at was unique, though. And you can see the examples I show on the right here. I started with some pretty simple examples. I started with 90. As you can see, 90 is the maximum number up to the limit 90, with a maximum number of representations, in this case 9. Then I tried with 300. 300 also turns out to be maximal. There's a total of, I think it's 31, is that right? Or 21. Yeah, there's 21 representations of 300 as a sum of two primes. And then I did it for some bigger limits. I did 1,000. I think 990 turns out to be maximal for that example. Pretty close to 1,000, but not quite 1,000. For that, you get 52 representations. Number grows within. I mean, it doesn't grow linearly. It's a little bit haphazard. There are some values of n that give you just a few representations. I think 38, for instance, only has two representations as a sum of two primes. I think it's the largest known value then with only two representations, if I'm not mistaken. And then I just, for some bigger values, the fourth example I'll show on the right here is actually the one we need for this problem. Turns out that for n, the maximum value of n equals 10,000, 9,240 does the job. The number 9,240 has 329 representations as the sum of two primes. And I also timed it because when you run it with bigger and bigger inputs, it gets slower and slower. I think I tried it with 1,000,000, but I didn't want to wait that long. And it's quadratic. It turns out that it grows by the square of n max. So when I tried it with 20,000, it took for 10,000 only took about 3 seconds to compute the answer. For 20,000, it took about 12 seconds. So I just didn't want to go any higher than that. And I think you can see the answer for n equals 20,000. The maximal value you get was 18,480, and that has 571 representations as a sum of two primes. So pretty straightforward code to write and run, and very fast too. So this really isn't a very hard problem to solve if you know a little bit of programming, just using a brute force search. And I got a very rapid response from one of my friends on classical mathematics. His first name's Oswald. I can't remember his last name, but he solved this in a few minutes. He wrote his own code to solve it. It wasn't Mathematica, but he had another program he used to solve this problem. So I congratulated him on it. Anyway, that completes my video. Thank you for watching. Long live math, and I'll see you guys next time. Bye.